Hello, hi, welcome to third class. So today we will learn about quadratic residue. Okay, in quadratic residue, so first we will see about the definition of quadratic residue. So let's say a be some integer, okay, positive integer, such that this symbol means such that, okay, this is for all, such that a, this notation, as I previously discussed, or we know this notation is nothing but GCD of a comma m is 1. Okay, just like GCD of 2 comma 3 2 comma 7 is 1, right? Like that GCD is 1. Okay, then we call such a as a quadratic. See, you understand this meaning? Quadratic residue modulo m if x square is congruent to a mod m has a solution. Okay, if suppose this, consider this equation such that am should be GCD 1. Okay, we call a as a quadratic QRMM. Okay, QRM if it is a solution. If no solution, then we will say a as a non-quadratic. Okay, so basic point is x square is a mod m. In small short, I'm saying such that a comma m is GCD 1. Okay, so if it is as a solution, then we call a is q or m. Notation is like this. Okay, no solution means what do you mean by solution? Means some x values which is satisfying this equation. Okay, that is called solution. So if no solution, then a is called non-residue quadratic modulo m. So notation is QNRM. Okay, this is small definition, bacha definition. So that's it. Okay, next definition number 3.2. So just like we are having some equation, a mathematical equation, means GCD of a comma m, this notation is denoted as a comma m. So see, just like we are defining legendre symbol, notation is bracket a comma b. Okay, just understand first legendre symbol. So let's say p denotes odd prime. Odd prime means p is a prime number, not a 2, but not a 2. Okay, next, this a by p, this legendary symbol, it can take values either plus 1 or minus 1 or 0. Plus 1 when means when a is a, tell me, when a is a quadratic residue modulo with respect to p. What do you mean by quadratic residue? Means this equation, means this equation should have what? Solution. And minus 1 when a is a QNRP. QNRP means non-quadratic residue modulo p. So when this when this equation has no solution. Okay, you understand? See, the equation is fixed, a square a mod. This can take any values and p is fixed from here. Just depending on a, it will change once either having solution or no solution. Okay, like that. And having 0 when means when p divides a. Okay, when p divides a means what? A equals to pk, where for some k belongs to z. Means to feel practically, 2 divides 4 or 3 divides 15, like that. So here 15 equals to 3 into 5, where 5 is for some 5, which is 5 belongs to. Okay, happy. So this is about legendary symbol. So now we are having some properties. So let's discuss these properties. Okay, first property is that this legendary symbol a by p, this is called legendary symbol. This legendary symbol is congruent to a power p minus 1 whole by 2 mod p. Okay, this is the condition. See, I am again telling you. See, here for this one, a can be anything. What? A can be any integer. There is no restriction that a and p always 1. Not like that. A can be anything. So This how you have to study the theorem. When you are studying theorem, whatever they given, only that much consider. Don't use your own brain. Okay, let P be an odd prime. Okay, bus here A is anything, any number, any number. Okay, that's it. So now we will prove this theorem. First this, see, once if you prove this theorem, these are like corollaries. Corollaries means this is the main thing you have to know. From this one we can derive everything. Okay, bacha. So let's consider this case. So here we have two conditions. Okay, what? Tell me, since A belongs to Z, we have two conditions. Tell me, P divides A or P doesn't divide A. If P doesn't divide A, since P is a prime number, then what we can conclude? A comma P is a. So this is the two case. Okay, very nicely. So again here what will happening? Tell me. We are having two cases. Case 1 and case 2. What? A can be a good looking guy, QRM, QRP, or A can be QNRP. Okay, looking very nice now. So see, so to solve this problem means, to solve this proof is correct, what we are doing means we are dividing, we are making into more cases. Means all these cases are nothing but this case. Okay, so if I can prove by taking individually, just like we have some divide and conquer. To solve a big problem, we will divide into many cases and we will solve these simple small sub problems like bacha. So we are divided into more, and so now consider this case. By considering this case, will you able to arrive this or not? Okay, similarly consider this case. Will you able to arrive this case or not? And consider this case. Will you able to arrive or not? By following all these three steps, if you can conclude this is successfully in everyone, then finally what you can say that hence theorem is proved. So this is our agenda. Okay, means agenda I mean this is our motive for this. Okay, we will do it one by one. Sure. Okay, anyhow come back. Okay, so now take case 1. Okay, when I am saying with my mouth case 1 A is a QRP, by default in your mind what you have to run? You have to think about like this. Okay, when I write like this, or even if sir write this, sir will not explicitly will tell that P doesn't divide A. In your brain automatically it has to be appear P doesn't divide B. Okay, this is bacha. Okay, this much you understand. Now see, A by P is congruent to A power P minus 1 by 2. This is I have to prove. So according to this case, what is the LHS value? Tell me. According to this case, what is this value? I told no. For QRP, what will the value of A by P? Legendre symbol.
Plus 1.
Value will be 1. Okay. Now RHS. So RHS A power P minus 1 by 2 mod P means mod P. If I can prove this as a 1, so am I happy? Am I done?
Yes.
Yes. Okay. So now our agenda is that we have to prove that LHS is equals to LHS is equals to RHS. Okay, LHS is 1. Now we have to prove that whether, see, whatever I am telling in my words, whether to prove that RHS is equals to LHS or not, I will write like this notation, SAR notation, question mark. So it is saying, it is means it is conveying that whether the LHS is equal to RHS or not, like conveying statement. Okay, so how to prove this one? So first, since P doesn't divide A, just in your mind it has to be appear, means whenever P is a prime and A is some number and P doesn't divide, then we can have a Fermat's theorem now. What is the Fermat's theorem? A power P minus 1 is congruent to 1 mod P. This is the Fermat's theorem in your mind. So just think that will you able to apply this here or not? like that means thinking approach should be there. Okay, so see, one more thing, we know that whenever we are saying A is Q or P, on background one more thing you have to run. What is this equation? Has a solution. Samjha? Has a solution for some x. Successfully has a solution. So I can write x square is congruent to A mod P. Okay. Now consider this equation. Means we know that if C is congruent to D mod M, then I can write C power cube equals to D power cube mod M. Why so? If I multiply many times, 3 times, it will become like this. Means I can write some for any power k. Similarly, I am writing this here. I am doing rising to the power of p minus 1 by 2. So what will happen? Tell me. So okay.
What happened to square?
2 cancel.
This one. A square.
It is there. Okay. Now again same concept, that since by Fermat's theorem we can say that this value becomes 1. So 1 is congruent to AP minus 1 by 2. So finally did we prove or not? LHS equals to RHS.
Yes.
So case 1 is happy. Case 1 is solved. Okay. Let's see about case 2. Case 2 is like some bit needed so much. So for this one you need to brush up about what is RRSM. Okay. Do you know what is RRSM? No? I will tell. Wait. For RRSM, see what is RRSM means. RRSM means it is basically bunch a set of integers such that every integer is a coprime to m. Okay, coprime to m means GCD is equals to 1, and in this set there will not be 2 integers such that both should be congruent to each other. Okay, we can say that from this set Ri is not congruent to Rj mod m for I not equals to j. This is also property is there. Okay, RRSM property. So see, if you are having this as a RRSM set, then take any integer. Okay, take some any random integer like 1 lakh or 2 lakh or 3 lakh, such that that integer should be a coprime with m. Okay, that should be coprime with m. I mean GCD x comma y m equals to 1. If it is so, then compulsory there will be one friend in this set such that that friend and this friend are both are equal. Even though it's looking like a 1,00,000 10 crores, but still on doing with condition mod m, it will reduce to particular number. Okay, see this is like RSM. Okay, you study from, like I told also, or you can refer again. So, okay, anyhow, see case 2. So in the case 2, like what we are doing means, so let's talk about some properties of RRSMP. Okay, so P is a prime number. Okay, so suppose let's say J sum belongs to the RRSMP, then there exists some J dash. Okay, some value such that what is happening, J into J dash is congruent to what happening, A mod P. So I am saying that I am declaring this statement. Okay, I am declaring with myself like this. So now you have to question that why so? Ray, why? Tell me the proof. Okay, now for this statement I am drawing the proof. Why I am telling this statement? Because this statement will be used in our result. So now let's see about why so, means why I can conclude like this if J is a RRS belongs to P. So let's say we know that some properties, this is properties you have to study from the last semester, means some course, but if you not just believe me. Okay, if J belongs to RRSMP, then their inverse also belongs to RRSMP. Okay, pakka belongs to RRSMP. Okay, happy. Let's call that inverse as a J double dash. Okay, we know that J into, this is normal bacha concept, J into J inverse, how much? 1 mod P. Okay,
Okay.
this is what I have written. Okay, J inverse in place of I have written J double dash. Now I am multiplying what? Multiplying A on both sides. So what will become? J into A double dash A into mod P. Okay, one more again property. See, property number 1 is that this property you have to remember. Property 2, behavior of that one is that, let's say if J belongs to RRSMM, then take some number. Okay, take some number which is co-prime with what? P. So if you multiply A into J, that will pakkali belongs to some number ASMM. This is the property. Very nice, na? See, what is the property means? J belongs to this, and such that, let's say take some integer A such that should be co-prime with P, means GCD is equals to 1. Then their multiplication must belongs to RRSMP. Now tell me why. Now I am saying that J double dash as a J dash. Okay, J dash will belong to RRSMP. See, why am I able to conclude that GCD of A comma P equals to 1? Because since P is a prime number, and in our by default case, what I have assumed that I told at the beginning, P doesn't divide CA, so I can conclude that P comma A equals to 1 for P is a prime number. This like small things you have to recollect and remember, like no one will tell. Okay, so J into J, finally we have concluded that J dash is congruent to A mod P. So let me continue. So J dash equal, okay, this much you understand, na? So finally what I am saying, since A is a QNRP, let's say just for fun J dash equals to J, then what will happen? Tell me. Then J square equals to A mod P. Did you see like this equation before? It's looking like this only, na? So since for this equation x square equals to mod P, we say that x has a solution and solution is equals to J, but that contradicts, na, our statement. Let me write. Let me write clearly, slowly, because of small details, like the video becoming like a monster, like more time taking, but it will be helpful if you listen in 3x or 4x speed. Okay, happy. Next, see, so J dash equals congruent to A mod P. Now what I am saying means, since A is a QNRP, I am saying that for all J doesn't equals to J dash. Now you have to ask me why. That's what your reason, na? Why so means I am telling. Suppose, let's say just for fun J equals to J dash, we will do by proof by contradiction. Okay, so this is my statement. So proof by contradiction means what? You will contradict the statement, means you will oppose my statement and follow and do some activities, and finally conclude that this activity and this activity doesn't match. Then you will say, oh sorry bro, you are correct. This is the whole contradiction step. So let's take J dash, then what will happen? Tell me. It will become A square mod P. Then what will you say? For this equation, what is the solution? Tell me. It has a solution x equals to P. You understand what I mean? See, just for analogy purpose, x square equals to 2x plus 1 equals to 0. This quadratic solution has a solution what? X equals to 1 and minus 1. Okay, like that I am saying that in place of x it is J, so I am saying that x it has a solution x equals to J. Sorry, it's a J, not P. Happy? But we know that since A is a Q and RP, does if it is so, does it have a solution? Tell me.
Yes.
Huh?
No.
Q and RP means does it have a solution or not for this equation? Q and RP.
No.
No. Why? See, at the beginning only I told na, like, see. Arey man. Basic definition. See, A by P. Here I told. See, it has a no solution. When will it has no solution? When A is a quadratic non-residue model. So this is my explanation. See, from this I can say that it contradicts our statement. So I can say that okay, you are correct, bro. So I can write that J does not equals to J dash. Okay. See. So finally, till at what we concluded means, see, I am saying that this has happened. Okay. So finally, let's go to real maza. Okay. Now we are having RRSM of 1, 2, 3 and P. Okay. Now I am applying for this equation pi. Pi means I am taking all the elements from J equals to 1 to P minus 1 by 2. Okay. If I multiply for each and every element, how many elements are there here? Tell me.
P minus 1. P minus 1 plus 1. P elements are there.
P minus 1, not plus 1. 1, 2, 3, 4, 5, 6 up till how many total elements?
P minus 1
minus
elements.
Okay. In this RRSM, one more property is there. One more property is there that we are having P minus 1 by 2 unique Q inverses. Means suppose I am having six elements, then let's say x1, x2, x3, x4, x5, x6, then x1, x6 is a one pair, means inverse, means x6 equals to x1 inverse, and x2, x5, and x3 and x4, like that. Okay. Out of 6 elements there will be how many unique Q inverses? Tell me.
Half 3.
So that's why I am written P minus 1 by 2. So now I am doing means I am taking the unique Q elements and multiplying each and everything.
Okay.
So for all the values of J is equals to 1 to P minus 1 by 2, I have multiplied. So since they are P minus 1 by 2, it has come out to A power P minus 1 by 2. You are getting my point? See.
Okay,
you understand, like, see, J belongs to RRSMP, and what is J dash? Like A into J inverse. Okay.
Yes.
Into J inverse. So now what we are doing means iterate over the elements J equals to 1 to P minus 1 by. Actually J is not 1 to P minus 1 by 2. What I mean to say means take elements, half of the unique Q elements. What? Half of the unique Q elements P by 2, and keep on multiplying.
Okay.
So what will happen here? Tell me. For everyone there will be the inverse P minus 1 like that. For 2, like 1 P minus 1, like 2
P minus 2,
and so on. For P minus 1 by 2 it will be P plus 1 by 2. If you multiply all these things, what will happen? It will look like 1, 2, 3, 4 and so on, P minus 1. So from this what you will tell me? So it will looking like a P minus 1 factorial.
Yes.
So what will happen? P minus 1 factorial. Now pi of A, how many times you are iterating pi? P minus 1 by 2. So how it will become A power P minus 1 by 2 mod P congruent. Okay. By Wilson's theorem, what does Wilson's theorem states? Tell me Wilson's theorem. Wilson's theorem states if P is a prime number, P minus 1 factorial is congruent to minus 1 mod P. Okay. So since this, from these two, can I write this one equal? Can I write minus 1 here? A power P, like I told in the previous class, minus 1 mod P. So finally we have reached here. So from by reaching here, can we conclude like this? Initially we have considered the case 2 as have A is a Qn Rp. That means that A by P equals to -1. So A by P is congruent to A power P minus 1 by 2 mod P. So this has been turned off P. So did we prove that LHS equals to RHS? Yes, no?
Yes.
So happy. So case 1, case 2 is over. Okay, let's come back to here. With case 1 successfully solved, case 2 successfully solved. Let's take about P divides A. So what will happen P divides A? So take LHS. So for this what is happened? For P divides A, we know that it will be 0. Yes. This value LHS will equals to 0. So consider RHS, A power P minus 1 by 2 mod P. So for P, A divides P divides A means what can I write? A, Pk equals to A, right?
Yes.
For some k equals Z. So can I write like this? A power P minus 1 by 2 mod P is congruent, means okay, equals to C. I am again telling this concept. C is congruent to D mod M, means can I write like this? I mean example 27 is congruent to 3 mod 6. Okay. So can I write like this? 27 mod 6 and 3 mod 6. What is the value of 3 mod 6? What is the remainder when 3 is divided by 6?
3.
What is the remainder when 3? Happy?
Yes.
So this is like bacha. I have told in the first class. If you not once listen from here only, or if you still feeling hurting, you can go in first class and you can watch. Okay. So I am writing like this. Okay. Since k, I can write like pk whole power p minus 1 by 2 into mod p. So you know that I have yesterday I told one, or you may remember like simple one. What is AB? A mod k into B mod k into like opening. Like AB mod k is I'm individually applying to each one. Okay, this you have to remember. Small things only make you sense. Okay, mod k. So for this reason I am writing like P mod P whole power P minus 1 by 2 into, tell me, K power mod P minus 1 by 2 whole mod P. So what is P mod P?
1. 0, 0, 0.
0. So 0 into anything what?
0.
0 mod P how much?
0.
0. Okay. So RHS also 0. Since LHS equals to RHS, we have happily solved. Means everything we have done successfully. Okay. This is that. So finally what we can conclude, tell me? This is the correct one. Yes, it's true. Satisfied. Happy? Okay, happy? Easy one?
Easy.
So let's come back to proof number 3.1.2. 1.2 means just I am writing like this. Okay. Okay, see, we are proving this statement. Okay, what is this? See, from this onwards you have to remember what? A by P. This is the legendre symbol A by P. Okay, legendre symbol A by P. So the main thing is that legendre symbol is always congruent to A power P minus 1 by 2 mod P. Okay, this you have to remember forever. Means by this only we will be able to do it. Okay. So can I write like this?
Yes.
Why? Because of theorem 3.1.1.
Okay.
3.1.1. Similarly, instead of A, I can write as B. If I multiply both two, what I am getting like this. Okay. ABP equals A power 1 by 2. Okay. Now leave everything. Now freshly consider this one. So instead of A, I am substituting AB. So what will happen? In place of A, AB will be there. So now compare these both things. compare both things. So is it so? Same only, na? So from this we can write this is as equal. Why? From this thing I am writing like this. Why means yesterday I told A is congruent to B mod P, B is congruent to C mod P. So then you can write,
then we can write A congruent to C mod P.
C mod P. Similarly, this congruent, this congruent. So this way, this two are congruent. Like that I have written. Okay, next one. A congruent to B mod P. Then we can write that A by P equals to B by P. Why means again similarly. So consider this as a okay. And again I am taking power P minus 1 by 2 on both sides. So it is happen like this, okay. This is from theorem 1.3.1.1. This is already known. Again this is already known. So from these things what we can conclude, tell me. Again same concept. A is congruent to B mod P M, B is congruent to C mod M, then A is congruent to C mod M. Since these are equal, can I write here these two are equal? Yes. Again this equal, can I write these are equal? Yes. That's simple, no? Similarly, finally, see, suppose now I am restricting here. Till now here A can be anything. What?
It can be
anything. But here I am restricting to co-prime. So if it is co-prime to P, then I can write A square by P equals to 1. Okay. See, again, just substitute A square by P in this 3.1.1. What will happen? This much happen. A power P minus 1. Since A comma P co-prime to 1, you have to remember that since P is a prime number, Fermat's theorems you can use. So if I use Fermat's theorem, I can write 1. Okay. Finally it is happening. Again similarly this also A square by P means what? Again same story. You substituted here, A becomes A power P minus 1, Fermat's theorem, and this is nothing but B by P. Okay. And last theorem, like, so if you keep place like 1 by P here, then what you will get? Can I write 1 comma P is 1 or GCD of 1 comma P is?
Yes, of course.
Like GCD of 1 comma 5 how much by A?
1.
1. Since it is happening, so can I write directly A equals to 1 here? Can I put A equals to 1? Then what will happen? You will get here, na? Nice thing.
Yes.
Okay.
Nice.
For this thing you have to again keep it. There is no there. So for here, see, I have written like this. A square by P equals to 1. A equals to 1, and so finally A by P equals to, in place of A I have kept minus 1. So minus 1 cancel here. Okay. Just remember one thing, one beauty thing. One beauty thing is that A equals to minus 1 whole power n. Something like that. Okay, like let's say like S equals to A minus 1 whole power n. One beauty thing is that generally if I move this thing to this side, what will happen? Tell me.
Plus will become positive and multiplication becomes division.
S by minus 1 by n equals to 1.
Okay.
So what can you write? S into minus 1 whole power minus n equals to 1. But what I am saying means, for such minus 1 and 1, I can write, instead of this, I can write like this. Instead of minus n, I can write minus n. Why so? Means just feel it. Okay. S equals to minus 1 whole cube.
Okay.
So that means S equals to minus 1 finally. So from my statement, just put 3. What will happen? Minus S equals to 1. So can I write S equals to minus 1? So that what I am saying means, this is beauty thing. Even though if you are having minus 1 whole power n, you can flexibly write wherever you want. So nothing will happen, no harm. So generally if I move this one to this side, what will happen? It should be become like this. It has to become like this, but still I can ignore minus n. I can write like this, as if I had not changed anything. So this is the beauty thing you have to remember. That's it. So that's all for this class. Okay, if anything needs to be correction there, like in my teaching, please tell in the to me directly or in the wherever you find me more means of communication. Okay, bye.